Continuing with the lab tour now. This is one of the best labs in my opinion, the Power Lab. Look at all this big, awesome stuff. Ha ha ha. Now the way this room works is we've got a circuit breaker panel right there with a bunch of three-phase stuff. Some of them go into these 3 transformers here, 2 kV each and 1 each per phase, and those just take the 208 and step it down to 115 3-phase. And then there's also a DC rectifier right here. Look at that, huge ass 3-phase transformer and some big silicon rectifiers there on these heat sinks. Got a relay there for starting the whole thing. Surprisingly though, it even has a copper oxide rectifier. That's a 3-phase rectifier, and I've already traced out the wire, and it's completely in parallel with the DC output is in parallel with the plus minus rails on this thing, and I'm really surprised. I have no idea what purpose that thing serves compared to these big ass diodes down here. But anyway, this whole contraption puts out 120 volts DC down through that little conduit, and all the conduit goes into this big box right here, this patch panel, up to the circuit breakers on the top, and then to these vertical channels right here. So that's the main output for each type of voltage, the 120 DC, 115 3-phase, and the 208 3-phase. And there's just some extra alternate bus bars here, but basically these wires come down here to all these other input connections, and they feed through, coming down the ceiling tiles here, to all these little boxes along the walls. So there's a 120 DC, 115 3-phase, and 120 208 3-phase. And we've also got some big disconnect boxes. That's what it looks like inside there. If I can fake this thing into thinking that the door is closed, then, oops, how does this work? There we go. I flip it up. Of course, everything's all turned off. I certainly wouldn't be dumb enough to flip this switch if there's live power being applied. Let's have a look inside this beast. It's so big that it has a door on it. So right behind this bundle of wire, and it's okay to be in here because all the circuit breakers are turned off. I'm in no danger here. And there's the big bundle of wire coming up and going to the circuit breakers and the vertical channels, horizontal patch channels right there. And then there's all the outputs to each individual lab station box. And supposedly some time ago, one of the previous power engineering teachers got the fancy idea to put these transformers in here. These are each one transformer per phase, but they're I think wired as 120 on primary and 12 volts only on the secondary. So they come in off of one of the 3 phases up there, and then the 12 volt outputs, they only go to, through those white wires, only to 3 individual terminals right there. Must have been just a one-time experiment, and it's been sitting here ever since. Who knows how many years or decades. We got some shelves on the wall over here. A whole bunch of really interesting stuff, mostly just for display to show students, you know, what this stuff looks like, how big it is when you see it mounted on the telephone poles or the power poles, and what it looks like inside. Huge 3-phase conduit, different materials, and even overhead power lines. You know, you can see how big and thick these things are and how they're made with aluminum on the outside and a steel core in the middle. big insulators. Oops, there we go. Insulators, huge ass fuse, more conduit insulator stuff. And then on the bottom shelf we got a bunch of motors. AC motors, DC motors, some more three-phase conduit, induction motors. A lot of them are actually cut, segmented in half like that, so you can see the squirrel cage construction and how these aluminum pieces, you know, they go through the iron core and then they're all shorted on the other end, right around there. This one here, this is actually a lightning arrestor that was outside my apartment, and lightning struck it one night and just completely blew out the bottom of it. It must have been a direct hit for such a violent reaction. So all this stuff inside is completely gone, and a lot of it vaporized too, I'm sure. But at least it's the nice porcelain insulator material that's left over. So when the power company came to replace it, I asked the electrician guy if I could keep this, and he said sure. Some other huge stuff we have down here is this big ass power supply. What is that? HP 6477C, rated for 0 to 220 volts and 50 amps, and that's DC. There's some huge capacitors. You can see the capacitor bank inside there. You really need big ass capacitor bank for all these high values of DC current. Some other stuff here, we got these little 1 kVA transformers, 120 and 240 volt coils on each side. Variacs, huge ceramic potentiometers. Look at this beast. It's rated 2.39 amps and 175 ohms. So I'll calculate how much voltage and power that is and lay it over the video here. And a lot more three-phase analog meters for AC power volts. Here's a three-phase power meter. And some single-phase stuff up here. A whole bunch of these old analog stuff. Most of these things we're keeping for the moment, but over the next couple years we're going to replace all these things with fancy new digital stuff. Here's another super big power supply. Input three-phase, of course, and output variable AC three-phase, and also output DC too. 125 volts up to 30 amps. And then there's this huge motor generator combination here with variable coupling between the two of them. Here's a look at the other side. General Electric direct current generator, 4.5 kilowatts. And the other thing is a synchronous machine. So AC motor 7.5 horsepower, or supposedly it could be a generator too, 5 kVA. And also the floor is littered right now with all these friction pony brakes and other big ass motors here, different generators and motors. I think these are 3 horsepower each, roughly, all packed underneath the tables down here behind the chairs. And those get used once in a while for classes and also for experiments, research. And it's not just a bunch of old analog big giant stuff. We do have some other stuff which I guess is kind of big, but it's all new digital stuff. So there's this whole rack mounted with all this different kinds of relays and voltage sensing, current sensing equipment. There used to be a whole bunch of current transformers and potential transformers on this shelf during the research. Just got another rack right here. It's empty right now, but I put wheels on it a while ago, and this will get used, I'm sure, for some kind of big high power experiment. Another thing that was just put together by myself and my lab assistant is this A-frame truck on which we put this huge piece of wood on here so that the teacher and his students could mount some stuff on it. This is a Sunny Island, SMA Sunny Island. Basically, it's a solar power charging and energy management system. So there's that thing, and then large breaker panel to go along with it. All mounted neatly on this cart. Even got panel on the back of it here for lighter stuff like maybe terminal blocks or low voltage power supplies or whatever. Even put a removable shelf down here and more storage space down there on the bottom. Right now it's got these 3-phase variacs, mostly just for counterweight, because you can imagine all the weight on this one side. I mean, it is stable, but during the move, it could be, you know, if this thing gets on an angle too far, then it's just going to tip right over. There's also this huge battery rack. Right now, all the batteries are on the floor down here, but they're big lead-acid batteries, and they were mounted 4 to a shelf on these 2 shelves here underneath the plexiglass boxes. And I actually made these boxes for the batteries years ago just to keep them clean and dust-free, and also to keep any debris or accidental short circuits on them, because that would be really, really bad with all the energy that's stored in those things. But anyway, it's stuff like this that the teacher and his students use to perform research on different ways and methods of discharging lead-acid batteries and solar management. There's some solar panels over there. I think that's a Harbor Freight solar panel system right there. So somebody was using that. And when we go to the new building, we don't have them right now, but over the next couple years, there's going to be some solar panels installed on the roof, and those will be used to charge batteries and basically simulate a solar power grid and do research with that, you know, trying to make things more efficient, more manageable, all that good stuff. Anyway, the students have been busy packing up all these boxes here full of stuff and the smaller equipment, smaller items, getting them ready for the move. And you've got these space heaters too. These are just used for dummy load, and it's 3 of them attached to each other like so. So you can have one for each phase. We also have some motor inverters on the wall, so students can do experiments with those things, and those will also be transported to the new building. And one final thing, let's have a look inside these cabinets. Oops. Gotta pull the cord on there. So we got some feedback stuff. Just a bunch of miscellaneous stuff gets used once in a while. There's some more motor drivers or inverters or DC motor controllers. Some National Instruments data acquisition stuff. There's all the individual modules that plug into this USB computer thing right here. So you do analog input, analog output, digital I/O, getting all kinds of information to and from the computer. And here we got some Fluke 75 multimeters, some switch boxes, Valhalla power analyzers, and some other things we don't plan on keeping very much longer is these diesel stroboscope. So it has a xenon flash tube right in here, and you turn the knob to make it flash at a certain rate. The digital LED display is calibrated in RPM. So you flash it, you turn this at a certain rate, so when you see the spinning machine going and with the light flashing on it, you turn it so that it looks like the spinning machine is standing still. But of course, there's much better ways to measure the speed of a spinning object. You just have a little dinky handheld tachometer, and that'll be good enough. So these will be I really don't want to get rid of them because they're really awesome. So I think I'll just keep these for myself and play around with them for a while. And we got some more three-phase power analysis module boxes down here. Finally, what electrical engineering lab would be complete without the cable rack? So just like all the cable racks, this one I made from scratch. You can see on the bottom here I got these big heavy iron cores from some homemade transformer that somebody had put together years ago. So I just took all the windings off of it and put the 3 individual iron cores down there to act as a nice heavy base for this thing. So that's a look at the Power Lab. And when we go to the new building, the new Power Lab is going to be a little bit bigger than this one, so more room to spread out all this stuff. And also moving this stuff, even though it is all big and heavy and cumbersome, I think it'll be quite easy because a lot of these things are already on wheels. So many stuff here that's already mounted on wheels. It'll be very easy just to push these things along, get them on a flatbed truck, and move them from one building to the next.